values. So let's take a look at some problems. And this first one here is one like you'll see in your textbook on problems 11 through 22 on page 262. And we're going to look at problem number 14. And here we have P of x is equal to, and these problems are already factored out for you. Not all of them will be, but these are. So we've got parentheses 2x minus 1, and then parentheses x plus 1. And we also have parentheses x plus 3. Okay? And that's how we start out. Okay, so our end behavior, I like to do that first. Okay, we have, basically we have x, right? And we've got x times x, and we got times x again. And so that's like x cubed. Well, that means that our graph is going to behave like a positive x cubed. And positive x cubed, we said that goes up and to the right, down to the left. So that's how our graph is going to eventually end up. So we want to graph that. We're going to put up and to the right, down to the left. Put little arrows there to show that that's how our graph should end up when we're done. Okay, now we want to go ahead and, well, it's already factored. So now what we want to do is to set y equal to 0, solve for x. Okay, so this will be 0 equals to, and then we already have it factored out, 2x minus 1 times x plus 1 times x plus 3. So we're going to set each factor equal to 0 now. X plus 1 equals 0. X plus 3 equals 0. Now we're going to add 1, divide by 2. And we get x equals to 1/2. Here we're going to subtract 1, and here we're going to subtract 3. Okay, so our x-intercepts are going to be at negative 3, 0, negative 1, 0, and 1/2, 0. So these are pretty small x-intercepts. So we're going to go ahead and kind of increase our scale a little bit. Here's negative 1, here's negative 2, and we're going to do this in increments of 1/2. Negative 3. And here's half 1, half 2, and so on. And so on our graph, we said that we had negative 3, negative 1, and 1/2. Negative 3, 0, negative 1, 0, and 1/2. So that means our graph is going to come up, back down, go through the y-axis, come up, and then go up from there, right? So it's good to try to anticipate what the graph's going to do. Now we want to find our y-intercept. So now we're going to set x equal to 0 and solve for y. So we go back to, we're going to make this P of x, P of 0 rather, is equal to, and then we have 2 times 0 minus 1, and then we have 0 plus 1, so wherever we have x, we put 0, and then 0 plus So, but we don't know, what we don't know is we don't know how high up this graph is going to come and then come back down, if it comes way down before it goes through the y-axis or what. We don't know what is going on in between it. So we've got to rely on our table of values. So what we're going to do is we're going to go to our calculator and we're going to type in our polynomial. And we're going to type in just the way we have it. We've got 2x minus 1, close that up, and then we've got x plus 1, close that, and x plus 3. Good idea to check it. X plus 1, and x plus 3. Okay, and then let's see what our graph does. Well, here's our table of values, and it looks like, we want to go ahead and get our whole graph in here. So what we want to do here is go ahead and go to Window, and our Y value, our Y part of our window is too small, so we're going to open it up a little bit. So we're going to make, let's see, our Y values went between 5, 0, 5, 0, negative 3, 8. Alright, so between negative 10 and 10 would be fine. So our Y min, we're going to set it at negative 10, and our Y max is a positive 10. And let's take a look at our graph again. And we got the whole thing this time. Okay, so go to second and table, and you see how we have negative 3. You want to do at least one more x value beyond your x-intercept point one way, beyond your x-intercept point the other way. Because sometimes you just don't know if it's going to come back up or not. So it's a good idea to do your table of values. And we need negative 3, negative 2, negative 1, or 0, and then so on. Okay? Alright, so we've got to, we know that negative 4 is a negative 27. So that's going to just continue on. And we don't need to graph negative 4, negative 27, but we need to show that it's going in the negative direction. And then we have 3, 0, negative 2, 5, negative 1, 0, 0, negative 3, 1, 8. And then 2, 45, again, it shoots up. You don't have to graph that, but you do need to show that it's going up. Okay, so let's put that in our table of values. And so we've got negative 4, negative 27, negative 3, 0, negative 2,